Welcome to Tutor KE Mathematics Form 3 Topic 2 Approximation and Errors, and I'm taking you through propagation of errors, which is the effect of errors of variables on the function which depends on the variables. In this lesson, we will look at propagation of errors in addition. So if we have a variable A and B being added to get Q, it means that if A and B have some errors, then it will be propagated to the answer Q. In this example, we are expected to find the absolute, relative, and percentage errors in the sum of 4.5 centimeters and 6.1 centimeters. So the two measurements are 4.5 and 6.1. It is important first to get the range within which the two measurements lies. So we start with 4.5, and the least unit for this measurement is 0.1. So its absolute error will be given by half times 0.1, which is equal to 0.05. To get the minimum value in this measurement, we take 4.5 minus 0.05, which is the absolute error, and this gives us 4.45. To get the maximum value for the measurement, we have 4.5 plus 0.05, which is the absolute error, and this will be equal to 4.55. Again, with 6.1, we have the least unit as 0.1, so the absolute error will be half of 0.1, which is 0.05. So the minimum value in this measurement will be 6.1 minus 0.05, which is 6.05. The maximum value will be equal to 6.1 plus 0.05, which is 6.15. Now, for us to get the absolute error in the sum of these two values, we take the maximum sum minus the minimum sum. We divide by 2. So we have the maximum sum, which will be given by the maximum value of 4.5 plus the maximum value of 6.1, which is 4.55 plus 6.15, and this gives us 10.7. The minimum sum will be given by the minimum value of 4.5 plus the minimum value of 6.1, which is 4.45 plus 6.05, and this gives us 10.5. So to get the absolute error, we'll take the maximum sum, which is 10.7, we less the minimum sum, which is 10.5, and we divide the answer by 2. So this will be equal to 0.2 divided by 2, which is 0.10. With the absolute error, we can get the relative error, which is given as the absolute error divided by the actual sum. Actual sum is also called the working sum, and it is given by the measurements which are stated. So we'll have our working sum or actual sum is 4.5 plus 6.1, which is equal to 10.6. So to get the relative error, we'll have 0.10, which is the absolute error, divided by 10.6, which is the actual sum, and this one gives us 0.0094 to 4 decimal places, and this is the relative error. Now we go to the percentage error, which is given by the relative error multiplied by 100%, and this is equal to 0.0094 multiplied by 100, which is equal to 0.94%. That is the percentage error in that sum. That's the end of the lesson. Thank you for listening, and I hope that you understood.